Okay, good morning. So today we are going to discuss Compton effect, very interesting and important derivation. It's very easy. It's just mathematical treatise. We use two basic fundamental principles in which generally in collisions in lower classes you have learned in collisions, elastic collisions, elastic collisions. In collisions, there formula we use. It's a simple phenomena, a simple thing. Okay, so in previous classes, we have discussed about electric effect. It seems many of you seen that recorded videos. I think some of students are pending still need to watch. Ask your friends to watch even. So, moreover, today assignment question also I think Compton effect. So now you listen parallelly, you learn it, write it. Okay, within this 40 minutes of the class, you can complete the assignment also. Okay. So in photoelectric effect, photon is used to get the electrons. So when photon is incident on metal, alkali metals, electrons, stream of electrons are out. Okay. So here, the basic thing what happened is the photon absorbed. Okay, the complete photon, that is complete energy of photon is get absorbed by the material or electron. Then those electrons will come out using that energy and with remaining energy move with some velocities. This happens in photoelectric effect. Compton effect is little different. And target element, heavy elements, if you consider heavy metals, when photon incident collides with electron, due to that collision, because some energy is absorbed by electron, the energy of the photon, that is, shift frequency takes place. Energy, initial photon energy is absorbed by electron. In the sense, the scattered photon will have definitely energy. So initially, if it takes collision with it collides with electron, a photon having frequency nu, and it is get scattered with the different frequencies. Electron also will come with some energy. This is the phenomena takes place. We'll see the diagram. So this electron. A photon, a photon of energy, a photon of energy h nu hits the electron, collides with the electron. Remember, this collision is elastic in nature. Elastic collision. What is elastic collision? Elastic collision is the collision in which conservation of momentum and conservation of kinetic energy takes place. Both the laws will be get verified, obeys this collision. That is total, no loss of energy or no loss of energy takes place. Whatever energy, with what energy this photon collides with electron, this is electron. Okay, what is the energy with which the photon collides with the electron? Some of the energy absorbed by electron, it will be come out of the metal, recoiled electron. Remaining photon also gets scattered. So this energy is equal to sum of these two energies. So no, there is no loss of energy. This is elasticalism. So law of conservation of energy we apply there. Similarly, in vector form, law of conservation of momentum also we apply. So when photon is paired with electron, when photon is collided with electron, the photon after collision with electron is get scattered with theta, and now it has frequency mu. Initial frequency it has nu. After collision, frequency becomes nu dash. That is energy decreases. Now energy after collision becomes h nu dash. Remember, nu dash is less than nu. That is, the energy of scattered photon is less than the incident photon. This is scattered. This is incident photon. Okay. After collision, this is scattered photon. This is incident photon. Incident photon energy is h nu. Scattered photon energy is nu dash. H nu dash is always less than h nu. That means frequency of the scattered photon is always less than incident photon. So some of the energy is absorbed by the electron. So electron also will be get scattered from the metal. It comes off. So it is called recoiled electron. Generally, we don't call it as scattered electron. We can call recoiled electron. That is recoiled electron. That also moves with some velocity. We'll have some minute that we'll discuss. Okay. So this is simple phenomenon. Photon is made to incident on electron, and the collision is elastic. After collision, some of the energy, the photon loses its energy to the electron, so that electron is get recoiled from the metal, and photon is get scattered. Right, photon is not completely absorbed by the material. Part of it is absorbed, remaining is get scattered. And the electron absorbs some energy from the photon is will be comes out as recoil electron. This is the phenomena taking place because it is elastic collision. Okay, so here we should apply two phenomena, two principles. It's a very simple phenomenon. You just this remember these points: law of conservation of atom, law of conservation of energy. That's all. You should be in a position to write, remember those formula. What is the energy of the photon? What is the momentum of the photon? What is the energy of the electron? Momentum of the electron. That's all. Then say it is very, very simple to write. Apply this formula here. Okay. So here, when you apply law of conservation of momentum, law of conservation of momentum is what? The algebraic sum of total momenta in a collision phenomena is zero, or more clearly, total momentum before collision is equal to total momentum after collision. That's all. Clear? Total momentum before collision is equal to total momentum after collision. How many particles are there? How many particles? One is photon, one is electron. Only two things are there. Initial momentum of photon, initial momentum of electron. After collision, final momentum of electron. Okay. Similarly, energy. Because energy is scalar, actually before after collision, just taking some you will get. Whereas momentum is vector, you have to take direction, the precise direction you have to consider. So in which direction the particle is moving and in which direction we are calculating moment. That's very important. So because we are considering direction here, we get components, resolving components phenomena. That point. It's a very simple thing. Resolving components is very, very simple thing. Just for small revision, F bar is a F bar vector. If you resolve it into components along axis with which it is making angle, that will be cos. Okay, horizontal component F cos theta. The other vertical one, which makes 90 degrees with that horizontal axis. Other axis is F sin theta. That is resolved into components. Okay, so first we will apply law of conservation of um, momentum. Okay, now what is the initial energy of the photon h nu? What is the initial energy of the electron? M naught c square, because rest mass, rest energy of the electron. What is the initial movement of the photon? Here for electron it is 0 because it is at rest, right? Energy of the photon h nu by c is the momentum of the photon. Energy of the electron is c square and its momentum is 0. After collision, okay. So what is the momentum? What is the energy after the collision of the photon? H nu dash. Okay. So momentum is H nu dash by C. What is the energy of the electron after collision? I'm writing direct m naught square c power 4 plus p square c square. What is the momentum? Let us take it as p. Momentum of the electron is p. Is it clear? Initial momentum, initial energy of the electron photon is h nu. Momentum is h nu by c. Okay, after collision, momentum of the photon is h nu dash by c. Energy is h nu dash. Energy similar for electron. The before collision energy of the electron is m naught c square, and momentum is because it is at rest before collision for electron. After collision, the electron moves with some velocity v, so momentum becomes p. The after collision, the energy of the electron is root of m naught square c power 4 plus p square c square. Now we'll apply law of conservation of momentum. After that, law of conservation energy. Okay. So applying law of conservation of momentum before collision, after collision, along x and y axis, because momentum is a vector, right? along x-axis, along y-axis. Components will be there. Okay. See here, while writing equation, I will explain over there. Before collision, what is the momentum of the photon? H nu c. Before collision, momentum of the photon is h nu by mass. Before collision, what is the movement of electron? Zero. Equal to after collision. After collision, momentum of the photon h nu dash by c, but along axis we are taking along x-axis. This momentum, this momentum vector, momentum of the photon, that vector makes theta angle with x-axis. So the x component of becomes h dash by c cos theta. X component of momentum of photon. Let us write here. At the same time, this electron also has momentum oblique direction p. It also should possess component along x-axis. So momentum of the electron along x-axis is p cos phi, because angle of scattering, recoiled angle is phi. Angle of scattering of the electron is theta. It is so the horizontal component of the electron is p cos phi. Let us write here. Clear? Now, along vertical direction. Along vertical, before collision, what is the momentum along y-axis? Whether you take photon or electron, there is no component along y direction, in the vertical direction. So there is no component of momentum of photon or electron, momentum of photon and electron along y-axis. So before collision, momentum is zero along y-axis before collision. So what is the total momentum after y-axis? Along in this direction. Okay, this is oblique direction. This is horizontal component. This will be vertical component. So h nu dash by c sin theta plus, what is the vertical component of this electron along y-axis, negative y-axis? So minus p sin phi. Clear? So we'll use these two equations. From this equation, I'm writing p cos phi, pc cos phi, c multiply both. You can cancel c on both sides. You will get c cos is equal to how much? See this equation. P cos phi is h nu by c minus h nu dash by c cos theta, right? So c is taken. I cancel c both. Here we get pc. Pc cos phi is equal to h nu minus h nu dash, h nu minus h nu dash cos theta. This is equation 1. We got from conservation of linear movement case along x-axis. Along y-axis, we'll write p sin phi how much? Okay, so PC sin phi is equal to h nu dash by c sin theta, and PC sin phi equal to h nu dash sin theta. This is we got from conservation of linear momentum along y-axis. Let us square, then we'll add. Square it and add. Okay. So this is equation 3. Let it be. Now apply law of conservation of energy. Okay. Law of conservation of energy. Applying law of conservation of energy. Total energy before collision, how much? H nu for photon plus m naught c square for electron is equal to total energy after collision. How much? Nu dash for photon and root of naught square c power 4 plus p square c square for this is a direct one because there are no components because it is a scalar. From this, remember here we have taken equation for p square c square. From this also you have to get p square so that you can equate it. Finally, we get the answer. Third, we'll write h nu dash this side and we'll square both the things. Right. Let us square. Okay. So after squaring, uh, right, we can cancel. I think dash square. This is h nu square plus h nu dash square minus 2 into h nu dash. Let us equate both the equations. When you equate them, equation this is equal 4. When you equate this equation and this equation, here we'll expand it. Right? Okay. After expanding it, see here. Here after expansion, h nu dash cos theta whole square, nu dash sin theta whole square. If you uh, if you take the h nu dash square common, cos square theta plus sin square theta will become. So here you will get uh, wait a moment. Okay, so from this equation, what we get? H nu dash square common. This is the we got here, and let us equate this. This is equation. Let us equate this equation 3 with equation 4. Here b square c square we got. Okay, so this is we got. Now you can cancel those terms both sides. What is the remaining? Minus, and this 2 also will cancel. Okay, so here in this one point we did not consider. Hmm. See here, a blunder mistake we did. Here applied this a plus b whole square formula minus that point we did not write. See, plus 2 h nu plus 2 h nu dash m naught square c power 4, that we did not take, and square is equal to h nu minus h nu square plus this thing. Okay, and plus 2 h nu dash m naught square c power 4. And while equating, you equate both the equations. Finally, to prove that, uh, final equation, lambda dash minus lambda equal to h by lambda dash minus lambda equal to h by m naught c into 1 minus cos theta. This is the final thing we get. Okay. So based on using that equation, let us draw a few graphs. Okay. What is by m? H by m naught is the Compton shift. Its value is 2.427 picometers. That you remember. Okay. 2.47 into picometers. Okay. If you draw the graph between relative intensity and wavelength of the wavelength of the photon, core and after everything total you get. So see this equation. See this equation. If theta is 0, cos 0 is 1, minus 1 0. So shift delta lambda becomes 0. There is no shift. Means there is no the after collision energy collision is not in place, we can think, or energy is not absorbed. Only single value is there for the single wavelength value is there for photon, because when it is incident, it is not get scattered. Theta 0 in the sense it is moving in incident direction. Okay. You have only one single value. Similarly, one graph. Let us take theta is equal to 90 degrees or theta is equal to 45 degrees. Cos 45 is 1 by root 2. 1 minus 1 by root 2, around 0.9 something you will get. 0.47 into 0.9. Okay. So that picometers distance is there. That means what? Between lambda dash and lambda, you have some difference. So lambda dash equal to lambda plus that value. You have lambda here. Somewhere here, you have lambda dash. Lambda dash is greater. That means what? There will be a shift between two peaks. Wavelength shifted. If you draw the graph, you must show some shift. This is dash. This value is lambda. Lambda dash is greater than lambda. Nu dash is less than u. Energy is less. Frequency is less. Wavelength is more. If you take 90 degrees, more shift takes place. Okay. So this is the Compton effect. You try it in between this point SB whole square 2AB I did not consider. Okay. So you take it and you will get the final equation. Simple derivation. Today you practice it, write the assignment. Okay. To the mail ID, submit to the Balaji sir. Okay. If you have any doubts, if you did not understand in between step, any step in between, you ask me on WhatsApp, call me on WhatsApp. Actually, I thought conference call. I suggested it, but day before yesterday on Friday, only 3 students joined conference call. It seems nobody has doubts. Okay, so anyway, you read it, practice it, write it. If any doubts, you ask me. Right? Again, read books, prepare for examinations, work seriously. Don't waste time. Don't waste time by playing PUBG, by watching movies. It is the time. Now you are approaching towards examination. Prepare well and practice all the mathematics, PPS, and physics mid assignments. Stay at home, stay safe. All the best. Today I'm ending the session. Okay, today the session is closed. You practice it. Okay. Tomorrow we'll discuss one more topic in this unit. Good luck.